Hello everyone, I'm academician Dr. Lilia. Welcome to Science and Me YouTube channel. The mission of my channel is to introduce you to popular science and to create a popular science encyclopedia on YouTube. We are back with an interesting popular science video. I would be very happy if you support me by subscribing to my channel and writing a comment. If you are ready, let's start the video. Space debris mitigation refers to the set of practices and strategies aimed at reducing and preventing the creation of space debris, also known as space junk or orbital debris. Space debris consists of defunct satellites, spent rocket stages, fragments from previous collisions, and other non-functional objects in orbit around the Earth. These debris particles can pose significant risks to operational satellites, crewed spacecraft, and future space missions. Mitigating space debris is crucial to ensure the long-term sustainability of space activities. Here are some key aspects of space debris mitigation. Removal of defunct satellites. One of the most effective ways to mitigate space debris is to remove defunct satellites from orbit. This can be done using robotic missions or technologies like space tugs or harpoons to capture and deorbit these objects. Deorbiting upper stages. Space agencies and satellite operators can design their missions to include plans for safely deorbiting the upper stages of rockets used to launch satellites. This prevents the creation of additional debris in orbit. Collision avoidance. Satellite operators can track the trajectory of space debris and maneuver their satellites to avoid potential collisions. This requires a network of ground-based tracking systems and coordination among operators. Space traffic management. Space agencies and organizations like the United Nations Office for Outer Space Affairs, UNOOSA, work on coordinating space traffic and sharing information on satellite positions to prevent collisions and reduce the risk of creating more space debris. Compliance with guidelines. International guidelines and best practices, such as those provided by the United Nations, the Interagency Space Debris Coordination Committee, IADC, and other organizations, help promote responsible space operations and debris mitigation. Design for demise. Satellites and spacecraft can be designed to burn up upon re-entry into Earth's atmosphere. This ensures that no long-lasting debris remains in orbit after the end of a mission. Limiting explosions. Minimizing the chances of explosions in space, which can fragment objects into smaller debris, is crucial. Proper disposal of unused propellants and careful management of energy sources can help prevent these explosions. Space debris research. Continual research on space debris and its behavior is essential for developing effective mitigation strategies. This includes tracking and characterizing debris objects and studying the long-term consequences of space debris on space activities. Space debris remediation. In addition to mitigation efforts, there is growing interest in space debris remediation, which involves actively removing existing debris from orbit using various technologies such as nets, tethers, and laser-based systems. Space debris mitigation is the set of practices and technologies used to reduce the amount of space debris in orbit around Earth. Space debris is any man-made object in orbit that no longer serves a useful purpose. It can include old satellites, rocket parts, and other fragments. Space debris poses a hazard to active spacecraft and astronauts, and it can also interfere with scientific observations. There are a number of different space debris mitigation measures that can be taken. Some of the most common measures include preventing the creation of new debris. This can be done by designing spacecraft and launch vehicles in a way that minimizes the amount of debris they create. For example, satellites can be designed to deorbit themselves at the end of their operational life. Removing existing debris from orbit. This is a more challenging task, but there are a number of different technologies being developed to do it. For example, some technologies involve using nets or robotic arms to capture debris and then deorbit it. Protecting spacecraft from debris. Spacecraft can be designed to withstand impacts from small debris, or they can be equipped with systems to avoid collisions. Space debris mitigation is a complex and challenging problem, but it is essential to ensure the long-term sustainability of space activities. Here are some specific examples of space debris mitigation measures that are being implemented or developed. NASA's Orbital Debris Program Office, ODPO, is responsible for developing and coordinating NASA's space debris mitigation efforts. The ODPO has developed a number of guidelines and standards for space debris mitigation, and it works with industry and other government agencies to implement these measures. The European Space Agency, ESA, has also developed a number of space debris mitigation measures, including a policy that requires all ESA spacecraft to be designed for deorbit at the end of their operational life. A number of commercial companies are developing technologies to remove space debris from orbit. For example, the company Astroscale is developing a spacecraft that will use a net to capture debris and then deorbit it. Space debris mitigation is a global challenge, and it is important for all spacefaring nations to work together to address it. There are a number of international agreements and organizations that are working on space debris mitigation, including the Committee on the Peaceful Uses of Outer Space, COPUOS, and the Interagency Space Debris Coordination Committee, IADC. Space debris mitigation is an essential part of ensuring the long-term sustainability of space activities. By taking steps to reduce the amount of debris in orbit, we can protect spacecraft and astronauts, and ensure that future generations can continue to explore and use space safely. Dear friend, I hope you benefited from the video. Thank you for watching today's video. If you enjoy content like this, please don't forget to subscribe to my channel and click on the notification bell to stay updated with new videos. Also, if you liked it, be sure to leave a like and share your thoughts in the comments. Looking forward to seeing you again with new videos. I can't wait to bring you more knowledge from the enchanting world of science.